Let's demonstrate virtual coupling of energy flow by using smart taps. This is the demonstration setup. It consists of 2 power sources, 2 lamps producing a load, and 4 smart taps. Each power source and each lamp are connected with smart taps. The black boxes are the smart taps. The 2 lamps are connected to individual power sources via one electric cord. The power source in this experiment is an electric power system. For actual use, however, the lamps would be connected to a dispersed power source, such as solar cells. The white boxes are independent watt meters that show output. The meters show an output of approximately 50 watt. We can monitor power flow and change settings on this computer. The black lines indicate physical wiring, and the red and blue arrows indicate virtual energy flows. As is shown here, this system controls energy flow, allowing the right power source to supply electricity to the right load and the left power source to supply electricity to the left load. First, we show fluctuations in the electricity supplied due to fluctuations in the output power from each power source. If you stop output from the left power source, the supply of power to the left load is cut. If you stop output from the right power source, the power output to the right load stops. Next, let's look at the electrical fluctuations from each power source due to load fluctuation. If you stop the left load, the power supply from the left power source stops, and only the right power source supplies electricity. This shows that the energy flow indicated in red becomes 0 watt, and only the energy flow indicated in blue supplies electricity. If you stop the right load, the power supply from the right power source stops. This shows that the energy flow indicated in blue becomes 0 watt, and only the energy flow indicated in red supplies electricity. If electricity is supplied to both loads, both power sources supply the electricity. Such energy flows are virtual and can be switched easily. Here, only the left load is on. In this situation, only the left power source supplies electricity. Only the red energy flow supplies electricity. Here we switch the virtual energy flows. Then, the power supply from the left power source stops, and electricity is supplied from the right power source. This shows that the power supply from the left power source stops. If you switch the energy flow back, only the left power source supplies the electricity. Next is a situation in which the one power source is stopped. If the left power source stops, the left load stops, and electricity is supplied only to the right load. If the energy flow is switched, then electricity is supplied to the left load. If the energy flow is switched back, electricity is supplied to the right light. As is shown above, cooperation among the smart taps on the power sources and loads enables control of the virtual energy flow. Currently, although limited to energy flow between a pair of power sources and loads, we are developing and testing a high-function smart taps and control algorithm to control more general energy flow, such as the supply of electricity to single loads from multiple power sources and supplying electricity to multiple loads from one power source.